Hello chemists. In this video we're going to take a look at aspirin. Aspirin is one of the most commonly prescribed drugs in the world, and it is in a class of medication known as the non-steroidal anti-inflammatory drugs, or NSAIDs. Aspirin comes from the meadowsweet plant, and the Latin name for the meadowsweet plant is Spirea ulmaria, and that's where we get the spur from in aspirin. And the A comes from acetyl. And let me explain how that works. So if we take a look at the molecule that makes up aspirin, it looks something like this, where we have a benzene ring, like this. And then attached onto the benzene ring, we're going to have a carbon double bonded to some oxygen here, and then an OH like that, and then an OH like this here. So this right here is the salicylic acid molecule. Salicylic acid. And salicylic acid is found in the meadowsweet plant. It's also found in the bark of willow trees. Now, as the name implies, it is an acid, and it can be irritating to the stomach. So people that have ulcers might not want to take this. And kind of an interesting story on this, there was a chemist from the Bayer Corporation, it was a German pharmaceutical company, whose father was taking a lot of salicylic acid and was developing stomach ulcers. And so this chemist wanted to find a way to make salicylic acid safer for his father to take. And so what they came up with was combining it with acetic acid. Now, acetic acid has the common name of vinegar, but it has a structure that looks like this here, where we have hydrogen, oxygen, carbon, double bonded oxygen like that, and CH3 like this. Okay, so this right here is acetic acid. Acetic acid or vinegar. We combine these two together and we end up with a new molecule. So I'm going to redraw this right here, my salicylic acid. Now that I've combined my salicylic acid with my acetic acid, I've made a new molecule here. This new molecule is now acetyl salicylic acid. Acetyl salicylic acid now has the A here for acetyl, and that's where we get the A from aspirin. So this right here was the new formulation that was a little bit easier on the stomach, and the chemist from the Bayer Corporation then gave it to his father, and his father was pleased. You know, talk about a proud parent there. Now, acetyl salicylic acid has some interesting properties to it. It is an antipyretic, which means that it helps to reduce fever. It's an anti-inflammatory, which means it helps to reduce inflammation. And it is also an analgesic, and that is to say that it helps to reduce pain. So aspirin does all of these things and does a wonderful job. But it also reduces platelet aggregation. That means it helps to prevent blood clotting. And that can be helpful for people that might be susceptible to a heart attack or a stroke. But the side effect of that can be it might cause bruising or bleeding for somebody if they become injured. So despite all the wonderful things that aspirin can do, it does have some side effects. And because of those side effects, people have come up with some alternative non-steroidal anti-inflammatory drugs, or NSAIDs, to help patients who maybe have fevers or inflammation or are feeling pain and can't tolerate aspirin. In this table here, I'm hoping to try to make some sense between the different NSAIDs that are out on the market and why you might choose one versus the other. Now, we should recognize acetyl salicylic acid. That is our aspirin. And then another common NSAID here is acetaminophen, and we might recognize this one as Tylenol. Ibuprofen, which we might recognize as Advil. and naproxen, which is Aleve. Now, aspirin, we might recognize this as an antipyretic. It helps to reduce fever. It's an analgesic, and so it helps to reduce pain. It also helps to reduce inflammation. It does have that side effect of it can cause bleeding, it can be irritating to the stomach, and then it also has a curious negative effect to it, and that is young people, children and teenagers who have had chicken pox or have influenza might encounter or run into something called Reye's syndrome. Reye's syndrome is an illness that can be fatal, and so it's recommended that if you have chicken pox or you have influenza type symptoms and you're young, you should probably not take aspirin. So these other NSAIDs here, Tylenol, Advil, and Aleve, they all also reduce fever, and they reduce pain. But Tylenol here is not anti-inflammatory, as is our ibuprofen and our naproxen. So why would somebody take acetaminophen or Tylenol when you have these other options available to you? And that has to do with toxicity. So Tylenol is toxic to the liver as well as a little bit to the kidneys. And Advil and Aleve are more toxic to the kidneys. So somebody who maybe has impaired renal function or kidney function might want to avoid Advil or Aleve. Tylenol, because it gets metabolized in the liver, if you have decreased liver function, you might want to avoid that. Some other things to consider is that dosing. So Tylenol and Advil and aspirin, you need to dose that about every 4 to 6 hours for it to have its effect, whereas Aleve, you can get by with about 8 to 12 hours, so it lasts a little bit longer. So those are a couple of reasons why you might choose aspirin, Tylenol, Aleve, or Advil.